This is section 3.4, Zeros of Polynomial Functions, part 2. We left off looking at how we can list all the possible rational functions, or possible rational zeros, and we're going to start right back there. So if you're like, wait, what are we doing? I would definitely go back to the first part of this section, because now we're going to take it a step further and use what we picked up in 3.3 with synthetic division. So first off, in order for us to list all our possible rational zeros, we're going to take our constant and write all the factors out for that for our numerator. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Okay, and then we're going to take our leading coefficient and write the factors out for that, plus or minus 1. Yay, that makes life a lot easier, because if I was to try all combinations with each of these over plus or minus 1, I would come out with that list in the numerator. So all my possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. It is so nice when the denominator is a positive 1 or a negative 1. So the leading coefficient, if it's a positive 1 or a negative 1, it makes that finding all the possible rational zeros a much easier feat. All right, now let's look at part B. It says use synthetic division to test several possible rational roots in order to identify one actual root. So basically what they want you to do, what they're asking you to do here, is to take each of those numbers, positive 1, negative 1, positive 2, negative 2, positive 3, each of those numbers, and use synthetic division, because we know that when we use synthetic division, I'm actually going to show you an example here, that if it is a solution, then our remainder will be 0. And if not, then it's not a solution. So I'm just going to take that first number. I'm going to take 1, put it in my pocket. Again, if you are confused about how we found all the possible rational zeros, I would go to the first part of 3.4. And if you are struggling with synthetic division, I would go to the videos for 3.3. Okay, so we're going to go ahead and take our coefficients. 1, negative 2, negative 9, 18. Start our synthetic division. We drop this first 1, multiply, get 1, add, multiply, add, multiply, add, and my remainder is not 0. Therefore, since my remainder is not 0, then I know that positive 1 is not a solution to this function, okay? So what they're asking me to do is to keep going down the list, to try negative 1, and then to try positive 2, and then try negative 2. Well, what if my solutions were at the very end of that list of possible rational zeros, right? That can be a very lengthy process. But if we just take our calculator and we enter this in, let me clear this out and enter in. Okay, got it typed in there, so I'm going to go ahead and press F6 to draw it out. Okay, definitely see some areas where it's passing through the x-axis. So G-solve, F5, F1 for root, and boom, it gives me x equals negative 3. So that it's only asking for one root of the given function. Now, if we were to do synthetic division with negative 3 in that pocket, our remainder would have been 0. Okay, so we would have done +1, -1, +2, -2, positive. Oh, well, on +2, it looks like we would have stopped and got one of them. Okay, but my point is that we would have had to go down the list, right? So that's so much easier just to plug it into your calculator. So that will help you identify your at least one root of the given function. But let's go ahead and arrow over. Okay, we see 2, so we have another rational function, and then, or a rational root, excuse me, and then go over to the right, and then we get +3. So that works out very nicely because all of our zeros, all of our solutions are rational. So we can literally just look on the calculator. You know, you have to understand how to enter it in, what you're looking for, but we know that it's -3, +2, and +3. Now be careful because here they ask for it, and sometimes students try to put all 3 there. It's only asking for one of the roots. So the very first one I saw was -3. Okay, then it says use the 0 from part B to find all the zeros of the polynomial function. Well, let me show you how we're going to use this, because in this case all of our zeros were rational, but sometimes that will not be the case, and so we need to know how to utilize this once we do have one of our zeros. Okay, so -3, I'm going to again take my coefficients, so 1, -2, -9, 18. Start my synthetic division, drop this 1, multiply, add, multiply -3 by -5, add, multiply -3 by +6, add, and boom. So for sure that is one of the roots. I saw that on my calculator, but now I just confirmed it with this synthetic division. Okay, now look at what we're left with. We're left with x squared. Remember before in 3.3 when we did synthetic division, what we would be left with, that leading term would be 1 power less than what we started with. So up here we started with x cubed. So this one right here is x squared minus 5x plus 6. Well, I could factor that, right? I could factor that and I could find my other two zeros. I could use the quadratic formula on this. And so once we get it down to a quadratic equation, now we have a couple of options how to find the other zeros. But this is really important to be able to identify, well, when would I use synthetic division in order to basically break down my function? So if it's x cubed, right, that's my leading term, I don't want to go from there and try to factor necessarily, because I want to get it down to that quadratic formula, the x squared as my leading term. And so that's how we can do it. We now have this tool where we can basically break it down a little bit and then use the quadratic formula or factoring. So if I was to factor this, I'd say, okay, this is x minus 3, x minus 2, set each of those to 0, and I'd get x equals 3 and x equals 2. And that's what we saw in our calculator, right? We saw that we had a 0 at 3, at 2, and at -3. And notice that -3 was the one that I removed with synthetic division. So when it asks for my solution set, I have to list all 3 of them. My solution set is -3, 2, and +3. So this will actually be how they will show you if you ask for question help in my math lab. it will actually show you how you're going to test each of the possible rational zeros, which, like I said, can be a very lengthy process. And so know that, yes, it'll ask you, what are all the possible rational zeros? But after you list them out, when it tells you to test them, you can just go ahead and graph that polynomial function in your calculator and identify at least one of the rational roots, and then use your synthetic division to break it down to a quadratic equation. Here it tells us that once we get it down, so notice in this one, right, it's x cubed as my leading term. So they went ahead and they listed all of the possible rational roots. They used synthetic division. Notice that here we did not get a remainder of 0. So I knew that 1, -1, +3 were not solutions, but here I do. So I know that -3 is, -3 is one of my roots. So then they took -3 out of the mix, right? So after they do synthetic division, this is what they have left. X squared plus 4x minus 1. My pen's acting up. They got that from there. And they took that and they used the quadratic formula on it. And by doing that, they were able to come out with these two answers. Now those are, that answer, both of those are obviously irrational answers. And so that's where you'll see, matter of fact, let me graph it real quick. Okay. So look at this, right? We see it. Notice what happens when I do G-solve. So that -4.2360679, that is clearly an irrational number. I cannot express that as a fraction. So that is one of the answers that I had to find through the quadratic formula. There's my rational root, -3. So that was the one that they used the remainder theorem to identify, but we could have just graphed it and found it. And then there's that other part of that irrational root. So here are my answers, with these two being those irrational ones. Okay, let's try it. Okay, they want us to list all possible rational roots of the equation. I'm going to take my constant, go ahead and write down all my possible roots, factors, ±1, ±2, ±4, ±8. Then I'll take my leading coefficient and write down all the factors, ±1. Makes life so easy because I know that all of these over ±1 just give me whatever value I see up there. So C is my answer. Now let's go further and find the actual roots of it. I'm going to graph it. Okay, got it in there. Let's go ahead and draw it out. Okay, G-solve root. I have -4 as one of my roots. Oh, let me put that at the bottom. Let's see what else we have. Definitely an irrational one right there. And another irrational one. Okay, so I have -4, and that's good because that's the starting point. So now I can use that in synthetic division to take it down to a quadratic equation. So -4. Notice that we're missing an x squared. There's no x squared in there, so we have to account for it. So I'll have 1, 0 for my x squared, negative 18 for my x, and then negative 8. Start your synthetic division, drop down that 1, multiply, add, multiply negative 4 times negative 4, add, multiply negative 4 by negative 2, add, and works out with a remainder of 0. If I do not get a remainder of 0, I need to check my math, or I need to revisit my graph because that means that negative 4 is not a solution. So this confirms that negative 4 is a solution, and now I'm left with x squared minus 4x minus 2. I'm going to go ahead and use the quadratic formula on that. 1 is my A, negative 4 is my B, negative 2 is my C. So quadratic equation. Square root of B squared minus 4AC over 2A. So we're going to plug it in. Negative B, make sure you account for that B being a negative 4, plus or minus square root of negative 4 squared minus 4A is 1, C is negative 2, all over 2A. So we have positive 4 plus or minus, I'm going to punch that in my calculator. Okay, in my calculator, it came out to 24 over 2 . I've got 4 times 6 underneath here, and I can do the square root of 4 is 2, so I pull out that 2, leaving 6 underneath the radical. And then I'm still not done because I can simplify here. I can divide all those by 2, and I get, sorry, I'm running out of room, 2 plus or minus 1 times the square root of 6 over 1. So I would just leave it like that. So 2 plus or minus the square root of 6. You can write those separately. So you can write it like this. Negative 4, 2 plus the square root of 6, or 2, oh, I left my 1. Oh, because it's a 1 times anything is itself, right? So I don't have to put that 1 in there. Okay, so I could write it separately or together. So really bringing everything together here using the rational zero theorem for listing all the possible rational roots, and then using synthetic division after we identify one of the rational roots, and then after that using the quadratic formula, so really pulling everything together. Okay, so they want us to use the rational zero theorem. And again, they're saying to use Descartes' rule. That's where you test each of those zeros and see what the remainder is, or those possible rational roots, and determine if it's a 0 by looking at the remainder. And so we're just going to check out our calculator. So let's first do all possible rational roots. Look at that negative 1. Say, okay, all of our factors for that is plus or minus 1. Then look at our leading coefficient. 8 plus or minus 1 plus or minus 2, listing all the factors, plus or minus 4 plus or minus 8. So all my possible zeros would be 1. That'd be that 1 over 1. Then we do plus or minus 1/2, plus or minus 1/4. We just go all the way down the line, plus or minus 1/8. Okay, now let's actually find, those are all the possible rational zeros. Let's actually identify the actual rational zeros. Go ahead and graph it. (8x to the third power minus 10x squared minus 7x minus 1. Okay, check it real quick. I always check it before I graph it so I don't do extra work and then at the end I'm like, wait, what happened? And I have to redo a lot of the work. Okay, go ahead and do G-solve, root. That's definitely an irrational zero. X equals negative 0.28077, yada, yada, yada. I'm going to go over to the right. I get negative 0.25. That's my rational zero. So I get negative 1/4. Let's see if we have any others. Oh, that's the other irrational one. So remember when we do the quadratic formula at the end, we end up with plus or minus. So that'll give you your 2 irrational zeros. So the one we're working with is negative 1/4, negative 0.25. So negative 1/4. Do not let the fractions scare you. I know usually when people see fractions, they're like, oh, but remember, you have a calculator that. So if you know the process of things and what you should be doing, then for sure you can just enter that into the calculator when you're going to be multiplying here. All right, let's go ahead and take the coefficients in our function there. So 8, negative 10, we don't have any powers missing, so we don't have to add a 0 anywhere. Negative 1, drop that 8. Negative 1/4 times 8 would be negative 8/4, so negative 2. Again, you can put that in a calculator, so no worries. Add it together, I get negative 12. So negative 1/4 times negative 12 would be positive 3. Add that down. Negative 1/4 times negative 4 would be positive 1. And I know that worked out because I got a 0, and that's what I should get since this is a solution to this function. So now I'm left with 8x minus, 8x squared, excuse me, minus 12x minus 4. I can go from there and use that as my A, B, and C, those coefficients and that constant as my A, B, and C. But I can also, if I'm able to recognize it, and if you don't, that's fine, but I can also say, oh, I'm going to go ahead and factor out a 4 here. And so what I'll be left with is 2x squared minus 3x minus 1. So I factored out, I said I factored out and it looked like I multiplied. So divided both sides by 4, and that's what I get. So that just gives me smaller numbers. It doesn't matter if you don't see that. If you do, great. If not, no worries. It'll still take you to the same answer. Okay, so let's go ahead and do our quadratic formula. x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Let's plug it in. So x equals negative b, negative 3. Make sure you account for the negative. A lot of times people will write the negative for the negative b in the formula, and then they'll leave out the negative for the actual value. Plus or minus the square root of negative 3 squared minus 4 times 2 times negative 1, that's my a and my c, all over 2 times a. Okay, simplify. So we have positive 3 plus or minus. I'm going to punch that in the calculator real quick. We got 17 over 4. Oops. And that 17 is prime, so I can't factor out any perfect squares there. There's nothing to simplify outside of the radical. So that's my other two answers. So for my solution set, don't forget the rational 0 that you started with. We have 3 plus the square root of 17 over 4, and then 3 minus 17, the square root of 17 over 4. And those are your three answers. Okay, doing the same thing here. Although they're telling us to use the rational zeros theorem to find the all possible rational zeros and then to test each of them, we're not going to test each of them, but we are just going to get the practice of finding all the rational zeros, possible rational zeros. So I take my constant and I'm going to write out all the factors for my numerator. So plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 9, plus or minus 15, plus or minus 45. I don't think I missed any. Okay, and then for our leading coefficient 1, that makes life so much easier because for the denominator, those factors are just plus or minus 1. And so now we know that all of our possible rational zeros are what's up here, because anything over 1 is going to be itself, right? Okay, so now they would usually have us test each of those to see which one we came out with a remainder of 0. But we're not going to do that. We're going to go ahead and graph them so we can at least identify, in this case, we would at least have to identify 2 rational zeros so we can use synthetic division twice to get it down to that quadratic equation. If it's x to the 4th, well, if we use synthetic division, it's going to take it down to x to the 3rd. That's going to be what we're left with, right? And so we will want to hit it up again. So let's go ahead and graph it. Okay, got it in there. Let's go ahead and draw it out. We'll do g-solve root. I see my 4 x-intercepts. So let's see how many of them are rational. We have x equals negative 5, x equals negative 3, x equals 1, and x equals 3. So awesome. All of them are rational. So we don't have to do any synthetic division. We don't have to do any quadratic formula. That's always a dream problem, right? So let's see. It was negative 5, negative 3, 1, and 3. So negative 5, negative 3, 1, and 3. If you see them all on your calculator and you can identify them, then that's your answer and that's it. You can move on to the next problem. I have a high suspicion that this one's not going to be so nice, so let's check it out. Okay, so let's practice finding all of our possible rational zeros. I have negative 18 as my constant, so I'm going to go ahead and write all the factors for that for my numerator. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Leading coefficient, 1, that's always so nice. So for my denominator, plus or minus 1. So all my possible rational zeros are going to be what I see in the numerator, because that over 1 would just be itself. Okay, let's go ahead and graph this. Okay, here we go. We draw it out, and I'm going to go ahead and okay, we get negative 3, negative 2. Oh, it's looking nice. And then not so nice. But that's okay. We got negative 3 and negative 2. And like I was saying in the previous problem, and because our leading term in this polynomial function is x to the 4th power, we need at least 2 of these rational roots so that we can chunk it down with synthetic division. So negative 3 and negative 2. Okay. So I'm going to go ahead and put that here. Negative 3 and negative 2. And then we'll leave it open because we still have 2 other answers. So negative 3, I'll use my coefficients. There's no powers missing. It's in descending order. So I'll use those coefficients: 1, negative 5, negative 47, negative 75, and then that constant 18. Those are some yucky numbers. Okay, drop that 1, multiply negative 3 by 1, you get negative 3, add, I get negative 8, multiply negative 3 by negative 8, I get 24, add, I get negative 23, multiply negative 3 by negative 23, I get positive 69, add, I get negative 6, multiply negative 3 by negative 6, I get, oh, there it is. This should be negative 18. See, but I absolutely knew, like, okay, that can't be right because I'm about to put positive 18, and positive 18 plus positive 18 is going to give me a positive 36, and I absolutely have to have a 0 here. Okay, so that works out. So now I have x cubed minus 8x squared minus 23x minus 6, but I don't even have to put the variables in because I know that I'm going to go ahead and continue and do synthetic division again to chop down another power. So negative 2 was my other rational root, so we're just going to drop these down and continue. Okay, so starting again with synthetic division, drop this down 1. Negative 2 times 1 is negative 2, add. Negative 10, negative 2 times negative 10 is positive 20. Negative 23 plus 20 is negative 3. And then negative 2 times negative 3 is positive 6. And boom, I get 0 again. That will always happen where you get a 0 for your remainder when you are using synthetic division with an actual solution. Okay, great. Because now I'm down to x squared minus 10x minus 3. So now that we have that, I can actually I could try to factor. Just looking at it, I'm like, two numbers that multiply together to get -3, but add together to get -10. Yeah, that's not happening. So I'm going to go ahead and use the quadratic formula. I have my A, my B, and my C. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, plug it in, plug it in. So x equals -10 plus or minus -10 squared minus 4a is 1, c is -3, all over 2 times 1. Simplify. I have 10 plus or minus, I'm actually going to do that math just in bits. 100 plus 12. So -10 squared is my 100, and then -4 times 1 is -4 times -3 would be my 12 over 2. X equals 10 plus or minus 112 over 2. I have a perfect square in that 112. Only because I peeked at how to break it down. I probably would have divided by 4 first and then had to break it down again, and that's okay. But I would not have seen naturally that 16 times 7 in there. Okay, so we're able to pull that 4 out when we do the square root of 16. And I'm still not done because I can simplify all of these by dividing by 2. So I get 5 plus or minus 2 times the square root of 7 over 1, which we could just leave that 1 off, right? So back up to my solution. My solution's up here. I'm going to erase that little portion of the 1. We have -3, -2, 5 plus 2 times the square root of 7, and 5 minus 2, oops, running out of room, times the square root of 7. Sorry about that. My point there is that you end up with your 4 answers there. Okay, so there is your 4 answers, and that's it.